Let me show you how you can subdivide a surface or a square, and also how to foreshorten it, so you multiply it, and why this is actually very important for perspective drawing. So let's go back to our square. So here's our square. And the reason why the square again is really important is because it can be used as a proportional measurement tool. So each side, for example, I could say is 1 unit. This unit could be, for example, meters. Okay. If I would like to subdivide this rectangle, I can draw 2 diagonals, and then where these 2 diagonals meet at the midpoint, I draw down a vertical. And there we can see now here I have, for example, half the distance, or 50 centimeters. So what unit system you use is basically up to you, but it's all kind of like in proportion or ratio. Now this square here, I can subdivide one more time. So for example, there, and there, and there. And you see now this actually is, again, whoops, wrong number, 1/2. This is 1/4. This is 1/4. Obviously, when I subdivide this, one more time, then actually we also have 1/8. So I hope actually that this quick demo shows you why I'm stressing so much the ability to draw proportional squares, because a square is a building block for a cube, and then cubes are the building blocks where we put our objects into, and the proportion of a cube can be used as establishing this correct size of an object. So let's say you would draw an object that is maybe 2 centimeters wide and 10 centimeters long. You just basically have to make a square that proportionally looks in the front like a 2 by 2 centimeter square. And then we have to foreshorten that square to the vanishing point 10 times so it looks like 10 centimeters. And that's actually what I'm going to show you in the next step, how we do foreshortening. Okay, so let's start actually with a horizon line. Somewhere down here I put a line. There I put another line and another line. So here we have our vanishing point. And let's say this is our square. Okay, so this square here, I would like to foreshorten and multiply here to the vanishing point. So how do I do this? It's actually quite easy. Our building block again is going to be our diagonal, but our midlines are not really very important, the verticals at least. But from this midpoint where the diagonals touch, we draw a line or ray to the vanishing point. And you see actually where this cuts the midpoint of this vertical. That's really important because now through that midpoint we draw another line, you see from one corner, and you see now this point here, that one is equal this point. So from there I can draw a line down. So now I have a 1 centimeter by 2 centimeter object. One more time. Now the thing is 3 centimeters long. One more time, it's 4 centimeters. 5 centimeters. Well, that's slightly off. And you see, the smaller your drawing is, the more important it is actually to draw really accurate, even on a computer. That's the reason why I always suggest to you to draw big on paper, because then inaccuracies are not going to destroy your drawing later. And now if you pay attention to, you see that these vertical lines, the more they go to the vanishing point, the distance shrinks, or in reverse, the more they go away from the vanishing point, the distance grows smoothly. And that's basically what you want to see, nice and smooth progressions. If you see there's steps somewhere or something feels too drastic, then maybe somewhere there's a problem inside your drawing. But this is basically how we do foreshortening and multiply objects. Let's do this one more time with an object that actually is on the ground. You will see it's pretty much the same idea. So here's our vanishing point. Maybe let's say here's my rectangle there and there. So this is actually slightly distorted already. You can see this angle here. So this line, if I measure it over by hand there, it's actually roughly here. Let's pre-check. Yeah, closely. You see actually that corner is out of my cone of vision, but that's okay. So maybe from here, somewhere there. Okay, that's actually where the line was. Okay, then there's my midpoint, and there. So then from here through there, zip, and one more time, and there, one more time, and there. So you see, pretty much the same. This is actually a nice drawing to demonstrate here again the problem of when you draw something that's outside the cone of vision, how something will start to get really distorted. See this square here actually, so this one looks kind of okay, but specifically this corner here is really bad. Now it's outside the cone of vision. So having covered that, actually we could take a look at how to mirror something. But before we do this, let's go back actually to our square. Okay, good. Let's put in a line and a line there. And what here, I should actually do it rather maybe this way, will be better, cleaner. Zip, and 90 degrees there. Okay, perfect. So how do we mirror something? And what I mean with that is, let's say we have a line there. I want to figure out how do I have to draw this line here. Currently this is actually really very easy because here this line ends actually on that diagonal. So in 2D I can simply draw a line over this direction, and when it hits the point there, then from there to there I can draw a line. Perfect. See, looks very symmetrical. Now let's say, well, what happens if maybe this line is here so it doesn't end on a line? Well, it's not really a big deal. The trick is really you have to work with your vertical lines, your diagonals, your horizontal lines, and your corner points, of course, and how those can be put into a relationship. So what do I mean with relationship? Now, let me see. So if I take this endpoint and bring it to here, what's being cut here? Actually, two things are cut. This point, here, there, and there. All these three are cut. And I will focus on this one. So I draw a line from this corner through there in here. And you see actually already that this line and this line are exactly the same. So from this point, now I draw over a line this direction, and ta-da, there's my endpoint I'm looking for. There. You see? Not very complicated. Now let's see if maybe I can find a different approach. So what happens if I bring this line over to here? Well, this line doesn't cut anything. Cut also nothing. What about this way? Yeah, that could work for sure. So it cuts, for example, this midpoint. So from here through this midpoint, I draw a line, and then from here, obviously, go over, and then there you see I have it. Works exactly the same. So you can see there are actually different ways how you can do it. I can, if I want to, also use this point. But the thing is, it's not really on the midline, it's on a side. So I have to bring this one over first with a horizontal line. And then from here, ooh, to there, I can draw a line. So it's kind of like an extra step. Extra steps can mean maybe some inaccuracies, little inaccuracies added together result into big inaccuracies. So always try to really simplify your steps. So honestly, focusing just on this cut point will be enough. Okay, so let's say I have something like this shape. No, that's not good. Let's say this way. Okay, not a big deal. So same thing, horizontals, horizontals. Okay. Now I need to figure out where is this point over here. So I do exactly the same thing. Go over through this cut, try to see. So it's there. And then this point, if I bring this one over, no, that doesn't work. Yeah, this works. Okay, so you see it cuts it there. So from there to there, zip. And then all you need to do is just connect the dots. Okay, so that's very simple, or that's a very simple approach how to mirror parts. Obviously, if, for example, you want to make arcs, it would be pretty much the same. So you plot actually dots. You need 2, 3 dots to construct an arc through. So then here I could make an arc and an arc. Okay. Now let's see how we can do this actually in perspective. Sounds awfully more complicated. Not really. It's pretty much really the same. So put down a line. There's my big rectangle, and I'm just making this thing much wider, so I have more drawing surface. Obviously, that's not a proportional square, but that's not the point. So first thing, I put down my diagonals. Try to do it good. Okay. And then I said like, well, let's have a line here. Okay. Let's put down actually my vertical line there. Okay. So from this point, actually, I draw a line now, not horizontally, because I'm drawing in one point perspective. Obviously, then I have to go to the vanishing point. Okay. And then from here, I go over to this one point, and I see that it cuts it there. So that tells me I can go from this corner point through where the midline is cut till it touches this point there, and there I have my part mirrored over. And you see actually how much that is distorted. And that's okay, because that's one point perspective, and things will look a little bit distorted. So let's say I have maybe this line. Okay, let's see how we can solve this problem. Maybe from this point I go to there. You see which point I'm cutting. So through the same point at the midline, I draw a ray down, and from here I go over to the vanishing point. There's this one cut. There, 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 there it is. Just now in perspective 1 point. So again, when you work with a square, and you have inside the square a line, the nice thing is you can just draw straight to the right or left side. But in perspective, we simply have to go to your vanishing point. And that's the only difference.